Hello grade 12s, welcome to my channel. Let us have a look at this question paper and gather some thoughts around it. So again guys, don't relax too much. The schools are going to open very soon. Please keep practicing in bits and pieces. Of course, take manageable bites of the subjects, and of course please read ahead. Get the ATP if you don't have it already. Get any ATP from any province, in fact from your province. Read on the topics that are going to be taught in term 3, while at the same time challenging yourself with the higher grade questions of all the topics that you have written exams on up to so far. Alright, so we're going to have a look at this KZN 2025 question paper and of course gather our thoughts around it. Now, instructions guys are very important. We need to really remember how to answer according to the specifications of each question. If not very clearly stated, we then use the general instructions. All right, so please read these with understanding, but remember this instruction is one of the key instructions when it comes to mark allocation. And this one says minimum of 2 decimal places, so it means we can do 2 decimal places or more than 2 decimal places. Here the lower limit is 2, but we can do more than that if you feel like it. Okay, given a chance to explain a thing, please give some brief motivations, discussions, but this part is where many students again miss it. Here a calculation is also possible. Even if somebody says explain, you don't have to explain in words. You can actually use a calculation to explain that particular situation. All right, or a formula can be used. You describe what is on the formula and perhaps some dynamics within the formula. That can be useful. So please guys, remember these things. They're very important. I know these are not normally clearly stated, and most of you run over these without even thinking because you think, this is, Trust me guys, the more you are aware of the detail in the exams that you are writing, the better you become at executing, all the actions necessary. Alright, let's have a look at the MCQs. In fact, we're going to keep it here for now. I will do the rest of the paper at a later stage. I just want to get you guys on the revising mood. But again, doing MCQs is a skill that we are going to deal with clearly. I've got a bank of MCQs from multiple years back, some tough questions even. So for physics, we are covered, guys. But for chemistry, chemistry is usually very easy. So I think the papers I have done are just going to be good enough. But I'll see if I cannot find a sample of MCQs for chemistry as well. Right, let's get to question 1.1. Here, a horizontal force F is applied to a crate, causing it to move. If it causes it to move, what is this? Newton's second law of motion, right? Over a rough horizontal surface as shown. Great. Now, it says the kinetic frictional force between the crate and the surface on which it is moving depends on. Now, what do we know, guys? Kinetic friction is the mu k times the normal force, right? So it's the type of the surface actually, because this coefficient tells us the type of the surface, and the normal force is dependent on the weight of this object and of course the surface as well. Right, so it says the force applied never. How fast the crate moves on the surface? Not necessarily. The surface area of the crate in contact with the floor. Okay, this one is a bit questionable. Yikes. But if the weight of this object is still transmitted, then the normal force will just be as good as when it is sitting on a bigger surface. So we can say, obviously, if we are comfortable with that, we take this one, the last one. So the upward force, so what is that? Exerted by the surface on the crate. This is the normal force. Now that is true. So option D is the best. Although C is giving us a bit of a situation, but we can take D confidently. So again, guys, work through each option. Do not just jump for the most obvious. Do not do that. It doesn't matter what your teachers say. Don't do that. It's suicide. Read through each options. MCQs anticipate a trick every time you do them. Yes, they can be easy, but do not take MCQs as they're going to be easy. Yes, they can be easy, but you see, you don't know which one is actually tricky sometimes. So do not take anything for granted. Read through each option and critically appraise it given the scenario, and then pick the best answer, okay? So don't just jump for the jugular. You will die here. It's easy to get sold poison and you swallow it. You realize when it's already inside you that, wow. Okay, you don't want to die a slow death, please. 1.2 says two forces F1 and F2 can be represented with a single force of 8 newtons, okay? So this is the resultant force. Okay? So it says now, if the magnitude of F1 is 3 newtons, right? Which one of the following can be the magnitude of force F2? Okay. So now, guys, this is not an easy question, by the way. I would put a higher grade question. A higher grade tag to it. Because how would you know? Now, remember, guys, I showed you a video from way back, 2005, when I did exams. I did it for grade 10s at first. Then I did that paper as a whole. So if you keep tabs with what is happening on the channel, you will not struggle to answer questions of this nature. But again, if you are those people who just go with the wind, you don't take notice of a significant issue. Again, how would you know it's significant? This is why when you come across a channel, don't just spot that channel. In my opinion, you should be watching every single video in the channel. Of course, give yourself time, but watch every single video. Get every idea presented. Don't be lazy, be active when you do this. You will never go wrong because you will just go through issues that can essentially challenge easily. So now, how do we do this question? Of course, guys, what matters here is that we always need to look for a maximum versus a minimum force, resultant force. Okay, let's just say this is going to be F res max and F res minimum. That is how we can get this right. Now, when would it be maximum? When F1 is F2? Usually when this one is in the same direction as the other force. Right? This is what presents the situation. When is it minimum? When the forces oppose each other. Right? So we know that this guy is the 3 Newton force. Now the question is, what should be the other one here? Now if we put 3 there, we know that the maximum is going to be 9. So, sorry, 6. 3 plus 3 is going to be 6, so that's less than 8. So it's already eliminating that. It's not possible. Now, we're not even going to go for the minimum because it's a waste of time. Right. And then we look at the 4. If we place a 4 here, the maximum is 7. Again, it's less than 8. This already eliminates this option right there. Now let's look at 10. If we put 10, maximum here becomes 13. That's greater than 8, meaning 8 is a possible resultant force. So 10 is winning for maximum. What about minimum? 10 minus 3 is essentially 7. Again, that means the range is going to be from 7 to 13. So this guy is within range. So this is good. So 10 is possible. Let's look at 13. If we place 13 there, the maximum here is going to be 13 plus 3, which is 16. Right? And then minimum is going to be 13 minus 3, which is 10. Can you see this is outside the range for this force? So this force is gone. And the best becomes C. Okay, guys, so please know your work. And do not take things you come across for granted. Because sooner or later, you're going to see what you missed. And you're going to cry. All right, let's move on. As you can see, you don't answer questions of this nature like that. It's a matter of looking at each one. Okay. Great. Okay, 2 hypothetical planets X and Y have the same mass, right? The diameter of planet Y is twice that of planet X, okay? Right, if the acceleration due to gravity on the surface of planet X is g, then the acceleration due to gravity on the surface of planet Y will be. So we know that g, not like that, g is the big G, the mass of the planet, I'll just say planet as in P, over the radius of that planet squared. It's always like that. Right, and of course, if you don't remember this, you can start here and say mg, which is the weight, equals big G, m of the planet, mass of the body in question, divided by the radius of that planet squared, or whatever is the distance between the two. If we divide by m, so literally that goes, so it means this m will eventually take that m, right? Because this is the mass of the body. So we can see that it becomes G, mass of the planet, over the radius of that planet, at least. So you can derive this if you don't know or remember it. But if you do, again on the information sheet, this formula is given. Right. So we know now that G, this is for planet X. Now what happens in planet Y? We know that G is going to be equal to the big G, mass of planet Y, divided by, we were told its diameter is double that, so the radius is going to be double the radius of the other planet. So this is going to be G, M, of course, since they are of the same mass, so we just say GM, P, right? And this is going to be 4r squared. We factor out the quarter so that we can isolate our GMP over r squared. And we know that this is G, so this is going to be a quarter of G. So this makes A the answer. Again, here you have to work it out. There's no guessing the answer. Make sure you do that. Of course, when you are comfortable with these calculations, you can actually look at what you're given and be able to figure out what the answer should be, provided you are clear on the formula that is needed. Okay, because I'm just doing all these calculations for you guys to be able to see where everything comes from, because not every student who's going to see these videos will actually understand and follow. Even with this explanation, some still don't follow. So the purpose of me being all tedious is just to accommodate everybody. But when my students are already high flying, I don't even show this. I just say it and go for the answer, and they understand what's going on. Now I told you that a ball is thrown vertically upwards into the air. We are to ignore the effects of air friction, which is good. The statement is golden. Now the net force acting on the ball when it is at its highest point is 0, no. Equals to the weight, definitely. It's less than the weight, never. Greater than the weight, never. Remember, the only force acting when we ignore air friction is the gravitational force, and it never is 0 at the maximum height. It's always the gravitational force. Right, so this one is a conceptual question. So this is an easy standard grade question. But that is based on understanding that topic and that subject and how, falling bodies work. Now 1.5, which one of the following statements is always true? See that? For inelastic collisions in an isolated system. Of course, inelastic kinetic energy is not conserved. But since this is a closed system, momentum will be, because once we talk collisions, this is momentum, energy, and power. All right, both momentum and kinetic energy are conserved, never. Both momentum and kinetic energy are not conserved, never. Momentum is conserved, yes, but kinetic energy not conserved, true, because that's the definition of an inelastic collision. Kinetic energy is conserved, never, in an inelastic collision. But the momentum, okay, this is already too wrong, okay. So obviously C is the answer. Please guys, don't just jump for the most obvious answer. Work through all the options. Weigh their weight and get the best of them all, okay. Do not play with your marks here. MCQs can be very easy if you know how to strategize around them. But if you're going to be anxious and you want the shortcuts like many of your teachers show you, you will suffer. And of course, they will not suffer as teachers. You are going to suffer as the student. 1.6. So please guys, I would plead though with the teachers themselves that they should use methods of teaching that are conducive for all students. Safety first. Teachers are supposed to teach safety, not ignorance. They should give students what is, at the very best, safe for all possibilities, rather than something that is of their preference, which in any case they're not sitting for these exams. So their preferences should take a back seat, mostly. But what is core to the subject should take the front seat, even if they don't like it. Because it's their students' lives at stake, not theirs as teachers. Okay, anyway, let's not politicize physical science. It's already very rough on its own. Now, an object moving horizontally at a constant velocity. So what do we know? Constant velocity forces are in equilibrium, balanced. This is the law of inertia, okay, Newton's first law. Now, suddenly encounters a rough horizontal surface, okay? That means friction is going to now be the force to then become the resultant force. Because remember, constant velocity meant equilibrium, no acceleration, no resultant force. But once we encounter this rough surface, it means friction is going to be the only resultant force, and that is going to change the state of motion of this object. Okay, now this is Newton's second law coming in. Now the object continues to move over this rough surface. Which one of the following statements is correct? The net work done on the object during the motion over the rough surface is 0, never. Positive friction never does positive work, but negative. Remember, work done by friction is opposing the direction of motion, and so it becomes negative work. So it's not constant. So C. Again, yes, that part of point C is quite obvious, but be in the habit of going through those options carefully so that no question can sway you, right? 1.7 says the hood of a car emits sound of constant frequency as the car moves away from a stationary listener. Wow, I wonder what are they trying to suggest here? Constant frequency. Okay. Do we ever really care about that? I don't know. Sometimes examiners, they just lose me with the way they think. Which one of the following properties of the sound heard by the listener will not change? Okay, obviously the speed of hearing it, right? But if it's like boo, you will hear the boo exactly at the time it's given, but its quality may not be the same because the farther it goes, the less it appears to be, right? So that's the Doppler effect. But yes, as the sound is given off, you will hear it at the same time. So that means the speed of sound should be the same. Obviously, this is correct. Frequency is always going to change. It will appear to become smaller. Both frequency and loudness, again, loudness changes depending on the proximity. As it approaches, it becomes bigger. As it goes away, it becomes, But again, loudness is an issue of the amplitude of a wave. Both wavelength and frequency, those are related. So definitely we can sit with A. Right. Now 1.8 reads 2-point charges, each with charge plus Q, are placed a distance d apart. Okay, the force experienced by each point charge has the magnitude of F. Now we're talking about Newton's third law of motion. Newton's third law, right? Yeah, that's the one. Action reaction coupling. Now the charges are now both doubled. So if we double the charges, we are literally quadrupling the force. Now I'm not going to show you the calculation because I'm trying to introduce you now into knowing how to work this out in your brain. You just need to know Coulomb's law, you need to know the formula, and you need to know what will change and how it's going to change. So if we're doubling each charge, it means the product is going to be 4 times, isn't it? So we're quadrupling the charge, right? And in essence, we are quadrupling the force as well, because that becomes a coefficient, right? And the distance between them is halved. Once we halve the distance, it means the r squared becomes a quarter, and a quarter, when we divide, is going to swing into the top. So we're going to actually multiply the force by 16. Now it says the magnitude of the force experienced by each point charge it's going to be 16F. Now do the calculations so that you don't just lazy around and watch things happen. You must make things happen, all right? 1.9 says the circuit shown below, the switch is opened. Okay, in the circuit, the switch is open. Right, we can see the switch is over here. Right. Now, it says the reading on the voltmeter is this V. Now we can see that this V is only going to read the voltmeter, the voltage across the terminals of the battery. Because if it is not connected, it's not going to read this section, but the terminals of the battery. So it should read 12 volts when that switch is open. So again, this is one of the videos, not videos, but I think, was it a Mpumalanga question paper or was it the Eastern Cape? I don't remember, but there are some question papers I have done where this idea was presented, and I kind of dissected it nicely for a student to be able to understand. So you better know your stuff, otherwise you are dead. Okay, it only reads 0 when the switch is closed because there's no resistance. As we know, the resistance of the connecting wires is negligible, meaning it's small. We don't consider it. So when the switch is closed, then there would be no voltage read there because there's no potential difference. Okay, just remember that. So don't be confused by 0. But this is essentially across the terminals of the battery when it's like that. All right, not a problem. Now 1.10 says, in the circuit below, the battery has an EMF E and internal resistance R with switch S open, right? The readings are registered on the ammeter and the voltmeter, okay? Switch S is now closed. Okay, good. So what happens when we close the switch here? That means we are decreasing. Remember, this becomes in series with the battery when this resistor is out. But when we close that switch, this resistor comes into effect. Now this is the parallel resistance. Now when this is parallel, we know that the resistor, since these are identical, it's going to be less than half of them, right? Is that so? Yeah. It's going to be less than them. It's actually going to be half of one of them. Okay, so we are decreasing the external resistance. And what do we know happens to the current? It increases. Right. So how do the readings on the ammeter and voltmeter change? So this is this dude and that dude. Okay. Obviously this guy should increase. There's no question about it. So these options are good. These ones are already bad. Now, question is, what happens to voltmeter? Does it remain the same? Does it decrease? This is now a question which needs us to work out some things. We know that EMF, the electromotive force, is going to be the external voltage plus the internal voltage, which is what we call the lost volts. Right? Right. But now, what did we notice? The current has increased because this thing is represented by the total current and the internal resistance. We saw that this guy increases. If that guy increases, this guy also increases. But we know this dude is constant. The EMF is constant. And for us to really measure up to the same EMF, if we're eating more, it means this guy should decrease. Right, so this means this is the answer B. Okay, guys. So as you can see, again, you need to know the relationships of what and what. Because that one, if you look at it directly, you will see that this is going to be I tot and R external. But what we notice is that this guy increased, this guy decreased. So you cannot be so sure what's happening. But if you put it side by side with its partner in crime, you start to notice that this should effectively decrease despite the current fooling you there, because this is giving you an ambiguous situation. So you need something else that works hand in hand with these two so that you can see that even though there's a bit of a mismatch there, in effect the entire thing will decrease. All right, so that's it, guys. I just wanted us to discuss these MCQs, nothing more. We're going to look at these long questions on a separate video. I just wanted to keep you guys awake and to show you some tricks, but not too much of them, right? Otherwise, I'll see you when I do see you. We should be starting our lessons on Monday. Please, guys, be on time, be punctual. Make sure over the weekend you ask your parents to go and get you some strong, internet connections. If not, rather ask your peers or your family members that at the time we conduct our classes, that they do not use that same Wi-Fi if you have a home Wi-Fi, so that you don't get interrupted. All right, because you need that strength, full force, so that you don't miss out on anything we discuss. So we're going to go through all these nice questions here and see how to handle them. So you can already see there's some nice questions here where the voltmeter is just put anywhere. Very interesting stuff. Last time I saw this was when I was doing matric. There was some study guides by J.M. Lucas, which we got from Star Schools. It had something like that. So you know what, these things are just reminding me a lot more about my matric here. Hey, so be very careful, guys. Me introducing those old videos to you, I mean those old question papers, wasn't a fluke. Just balance your stuff. You will never suffer. All right, guys, goodbye.